The paper starts out in the rear room, where the rear room operators are going to be diligently working to keep paper going up through the press. Now you have control over the reel stands, and now you have control over the amount of tension that's going to be pulling back on the webs. After it leaves the reel stand, it goes up through the unit, where the unit operators are going to be setting ink. After it goes through the unit, it's going to be going over a series of dead pipes. They're called dead pipes because they do not have a motor spinning them. They spin due to the friction of the paper running across them. It'll go across an anti-wrap roller, over more dead pipes, and then eventually to the RFB. RFB is the roller front of bar, and that is a motorized roller. We also call it a driven roller, or you might also call it the drag roller. After it gets past the drag roller, it goes to the turn sheet, and then may or may not split, and then it goes from the turn sheet across more dead rollers until it gets to the RTF. The RTF is the roller to former, and that is another driven roller. From there it gets split and separated onto two different former boards, and then sent down to the nips, where it gets collated with the other balloons, and then sent to the folder. The folder then chops off sections, folds it in half, and then sends it out to the packaging department. Now that's just one lead. If you add in all the other leads, that is your responsibility. And if anything goes wrong from the rear room to the folder, that's also your fault. So you've got a bunch of people working around you, but essentially you're the one that's actually running the product, because you're in control of the entire press. And you have to balance the tension as the paper is running from the reel stand to the folder. And we're just talking about paper here. Paper is very fragile. It rips extremely easily. It's in fact a miracle that it makes it through the press and that we get a product out every night at all. This is the folder. As the paper comes down, it gets stuck with pins. The pins drag it across the folding cylinder. Then the cutting cylinder cuts off sections of the paper. The tucker blade pushes it into the second fold. The second fold pulls it through. As the tucker blade pushes it into the second fold, the pins have to release so that the paper can drop onto the flywheel. Then the pins re-engage to grab the next sheet of paper. The flywheel aligns the paper so that it will be dropped onto the conveyor evenly. Then the conveyor takes it on to packaging. Before you get started working on the folder, the first thing you want to do is put on a safe. This is the front of the folder. On it, you're going to see 4 wheels. The first wheel on the top right is the pins. These are the pins. What this wheel is doing is it's changing the release point and the re-engagement point of the pins. So you can have the pins engaged longer, and it will drag the pins across the paper, and it will pull the paper tighter across the folding cylinder until the tucker blade pushes it down. If you have the pins engaged too long, it will drag lines into the paper and give you a poor quality product. But if you don't have the pins engaged long enough, then the tucker blade will hit in random areas and you won't have a clean lap. The rule of thumb is the larger the product, the more pins you need. This is the lap wheel. All this is doing is retarding or advancing the tucker blade position. The tucker blade pushes the paper into the second fold approximately halfway through the paper, but you can make the lap change so you can have what we call a full lap, and you can have a reverse lap, and you can have no lap. This is the lap. This is a full lap, this is no lap, and this is a reverse lap. The point of these is dependent on if there's going to be things inserted in it. So if there's going to be a product with, we'll say, the comics and advertisements dropped into it, or if you need to run the main off of 2 runs, so you're going to have the main run and then also the classified run, then you're going to need a lap. And what that'll do is when packaging receives that copy, fingers will drag across the paper and pull it open, and then it can drop the inserts in. And that way this can be automated and faster. If there's not going to be inserts, then you have no lap, and that'll just make a clean quality product. And the reverse lap is usually used for what we call a stitch and trim. So this is a product that's going to be stapled in the center and then cut along the sides. If you don't know what setting you're supposed to use, the packaging department will tell you which kind of lap that you need. If you look at the top of the wheel, you'll see decrease to the left and increase to the right. And if you spin the wheel all the way to the right, it'll give you the full lap. And you can tell when it's there because the indicator in the center will be flush with the outside of the wheel. If you spin the wheel to the left, then you'll be getting to the no lap and then to the reverse lap. On a reverse lap, the indicator will be pushed all the way so that it's flush with the inside of the wheel. The little blue line in the center is the indicator for no lap, so when the inside of the wheel is flush with that line, then you have no lap. If you look on the top of the lap wheel, you'll see this little line that we carved into it. That's an indicator that says don't go beyond this point when the indicator is all the way out. The reason for that is because if you do go beyond that, then this wheel will actually bind, and it takes quite a bit of effort to get it to unbind. Something to know about adjusting the lap is that it's going to be affected by speed. So you can see here that I've got the folder on a walk, and I'm going to show you full lap, no lap, and reverse lap. And you can see that they all are more than full lap. But as you're running, that lap is going to change. And the faster you go, the more it's going to change. So if you make an adjustment for a slow speed and then you increase the speed of the press, you're going to have to make another adjustment later. This is the band wheel. These are the bands. On the folder, these pieces of metal will bend out and stretch in to effectively increase the circumference of the cylinder. And as you increase the size of the cylinder, it's going to be pulling harder on the paper. The rule of thumb for this is the smaller the paper, the more bands. There's a couple things to keep in mind. The first one is that the bands themselves can actually be bent from wear and tear, and that the paper itself may be a different weight than what you're supposed to be running. The best thing to use to check the actual band setting is the indicator that's on the folding cylinder. Now if you open up the door to the folding cylinder and then spin it around to this indicator, you'll probably have to blow it off to see it. You can see this indicator here. So check the indicator, check to see where it's actually at, and then spin the folder around to make sure that all the other indicators are in the same spot. There's 3 sets of bands, so there'll be 3 indicators. The next wheel is the second fold wheel. When the tucker blade pushes the paper down, the second fold is what grabs the paper and pulls it the rest of the way through, then delivers it to the flywheel. And the second fold is just 2 rollers that spin with each other to pinch the paper. You can see on the wheel the indicator that there are several lines going around, and each line indicates a weight of paper. So if you have a heavier weight of paper, it's going to be thicker. That means you're going to need to use a wider setting. And if you have a thin weight of paper, it's going to use a thinner setting. And if you look on the left side, you'll see the weights of the paper that each line indicates. Something to keep in mind is I have once seen the needle actually stick to the wheel and spin all the way around, so you can't always trust it. If you look behind this wheel, you'll see another wheel that is the degrees that the second fold is going to be opened on either end. So if you want it to pinch more on one side of the paper, this is the wheel you use to set it. And the indicator is in degrees, that's degrees of arc. And if you want to move it, first loosen up the bolt on the front of the wheel, and then you can spin these 2 wheels independently until you get the measurement that you want. If you do ever change it, please set it right back to 0 degrees when you're done. Line up the line on the rear wheel with the degree measurement on the front wheel that you want, and then lock the bolt back down. You have the capacity to move 2 of these wheels electronically, and that's the band wheel and the second fold. If you look at the bottom left, you'll see pin, second fold, lap, and running band, and you'll see that they're listed twice. The buttons on the left side of the screen are for the operator side folder, and the buttons on the right side of the screen are for the drive folder. This is the delivery pin. The delivery pin is just a bunch of belts that the flywheel delivers it to, and then those belts carry it onto the conveyor. On most presses, this pan is important because if you have it set improperly, the flywheel will just throw the papers onto it and the papers will not come out straight. So you have to do a lot of tweaking with it. On this press, we're fortunate that we don't actually have to touch that. We have a cog belt on this folder which does all of that for us. When you start running the folder, wherever the pan is, just leave it there. But it is important to know how to adjust it, so in case you ever have a problem, you'll be able to use it as a troubleshooting tool. The pan goes up and down, and it also changes angle. At the bottom right, you'll see these 2 wheels, and the top wheel makes the pan go up and down, and if you turn it to the right it goes up, if you turn it to the left it goes down, and the bottom wheel changes the angle. If you turn it to the right, the angle goes up, and if you turn it to the left, the angle goes down. If you do for any reason change any of these settings, make sure you count the number of turns that you put in, and whenever you go back, put in the exact same number. That way, wherever you moved it to, you can move it right back. This is the cog belt, and this is the wheel that adjusts it. When you're adjusting it, you're taking the entire assembly and moving it up and down, and what that's going to do is it's going to grab the paper and strip it off of the flywheel to lay it onto the conveyor nicely. Loosen the nut so you can start moving it, and then if you turn the handle to the left, it'll make the assembly move up, and if you turn it to the right, it'll move the assembly down. And what that'll do is it will advance or retard the moment that it strips the paper off of the flywheel. The rule of thumb is for a small product you want to have the cog belts down, and if you have a large product you want to have the cog belts up. There's another wheel that looks the same and it's just to the left. If for any reason the cog belt went out of time, you would have to change it. And the cog belt is driven by a chain. This wheel adjusts the take-up gear, so if you loosen it, it will also loosen the chain, and then the chain can slip a gear. You will notice that if you ever try to adjust it, that you won't be able to, and that's because it requires an Allen to loosen it, but if you do try and press hard enough, you will be able to move it. So just rule of thumb, don't ever touch this, unless you intend to adjust the timing of the cog belt. All around the folding cylinder are these guides to guide the paper as it's going around the folding cylinder and to prevent it from flapping. And the first set of guides is attached to what we call the suitcase. The suitcase is a large block of metal that is also connected directly to the vacuum. The vacuum is necessary because the folder creates a lot of dust that needs to be vacuumed up so it doesn't get clogged in the folder. Every once in a while you should remove the suitcase and clean it out just to make sure that you have proper airflow. But if there's a jam in the folder, you might also have to remove it for that. The way you do it is you remove 4 bolts, and they're all finger tightened. There's 2 on top, just grab them and loosen them all the way up, and 2 on the bottom. After they're loose, you can grab it by the handle and pull it out. and it's going to be quite heavy. After it's out, you can see more of what's going on inside the folder. You can also see the vacuum area, and if there's anything jammed in there, you can clear that out. It is safe to say that the suitcase does not get removed very often, so every time you remove it, you should clean it. You can get the air gun and blast all the dust off, and you can also blast out anything that's stuck in the vacuum area. The important part of the suitcase are these guides, and just get some solvent, clean off any of the crud that's on it, and then you can stick it back in the folder. Try to be careful when you're doing this not to bang it around too much, because you don't want to damage the finish on the suitcase, and you also don't want to damage the folder. After it's in, tighten up the 4 bolts and you should be good to go. And this is what we call the air logic, or the safety switch system. It's connected to a series of pressure valves that when triggered will stop the press immediately. The first one you're going to have to get used to firing is the second fold. So if too much paper goes through the second folds and it pushes the second folds too far apart, it will stop the press. When that happens, what you have to do is back off the second fold, loosen it up a bit, then reset the air logic, and if it goes from green back to red, then you're good. If not, then you have to loosen up the second folds more and try it again. Then reset the air logic, then you have to go back into the quiet room and reset the folder. After that, come back out, make the press hot again, try to pull whatever got jammed down and out, and then tighten the second folds back up again. Quite often when this happens, it'll happen more than once, so you have to be ready to get the second folds tightened back up and get everything pulling straight again. So if it does happen again, just repeat the process, open up the second fold some more, clear the air logic, and then reset the folder. Keep on doing that until you have good paper going through. There's 3 more safety switches. The next one is the backstop. The backstop is a door behind the flywheel, and if for some reason paper doesn't get delivered into the flywheel correctly and it goes behind the flywheel, it will likely push that back door open and it will trigger that valve. When that happens, just push the door the rest of the way open, pull out whatever paper's there, and then slam the door back shut. This safety switch also has a valve connected to the pan. If there's paper jammed between the fly and the pan, it will trigger that valve and you'll have to remove that paper. Once all the paper is removed and the door is slammed shut, clear the air logic and reset the folder. The next air logic switch is the cam door. Chances are you're never going to be messing with this cam door, but if there is a problem with it, make sure you clean all the area around the cam door before you remove it, because you don't want any dust or junk falling into the cam. Then you can loosen these 2 wheels to pull it all the way off and see into the cam. Installation of the cam door is reverse or removal. Place it back in the same spot and tighten the wheels down, and then you will hear the valve. After you hear it, reset the air logic and reset the folder. The last air logic switch is to change the cam from straight to collect. Move around to the start side of the folder and pull out whatever paper is in there. This folder is shaftless, so if it's on a stop, you can grab the folder with your hands and move it. If you're going to move it, then you want to move it in the direction that it normally travels. The first thing we're going to do is move the spacer for the knife block. There's 2 knife blocks, so you want to move the folder until you see the knife block with the C at the bottom left. That's C for collect. If there's an S on the bottom left, then that means you're moving the wrong one. On your left, you're going to find a gray bag with all the tools you're going to need to change out the folder, and the first tool you're going to need is the large T handle. On the knife block, you're going to find 4 bolts, and you want to take them all out, but also keep them in the order of where they go. After all 4 bolts are removed, grab a pry bar, put it underneath the right side of the lockdown block, and pry it out. The spacer plate will come out with it, so make sure you do not drop it. Anytime you remove a component like this, it's a good idea to blast it out with an air gun so that you remove all the dust and debris that's in the way. The knife block itself can also be removed, and you can blast out all the paper dust that's in it and clean out as much as you can from the cutting cylinder. Flip the spacer plate over and put it so the bolt holes line up with the collect side of the cutting cylinder, and then use 2 of the small bolts that'll be in the gray bag to lock it down. Then you can drop in the knife block and make sure that the hole in the bottom of the knife block drops onto the peg and the cutting cylinder. This is to make sure that it is properly aligned, and if you look at the bottom of the knife block, you will see these small lines, and those are holes so that the pins can go through it. If the knife block is not aligned perfectly, then the pins will just break right off. Next, it's time to drop in the lockdown block. You have to make sure that the bolt holes are lined up with the bolt holes in the cutting cylinder, and an easy way to do that is just to line up the edges of the lockdown block with the knife block. If it's lined up properly, then the bolts will drop straight through. Next, it's time to put the 4 bolts back in. Make sure you're putting the correct bolt back in the correct hole, and get them all started before you start tightening them down. You want to make sure that they all fit in nicely. After they're started, you can start tightening them down with the large T handle. Start with the inside bolts first, and then do the outside bolts last. I tighten them down in order of 2, 3, 1, 4. After they're tightened down as tight as you can get with the T handle, then grab the socket from the bag and the torque wrench. I've asked a lot of people what the torque specification is for these bolts, and I've gotten a lot of different answers. I know that we started with 35 pounds, and then we went to 32 pounds, and then 30 pounds. Most people tighten it down to 30 pounds, but if you ask press maintenance, they're going to say 35 pounds is fine. I personally always tighten them down to 35 foot-pounds. To set the torque on this wrench, push down on the lock and then spin the handle until the 0 on the indicator is lined up with the 35 on the wrench. Pull the wrench until you hear a click, and then that bolt will be set to 35 foot-pounds. Tighten the bolts in the same order, 2, 3, 1, 4, and then do it over one more time just to make sure. Always make sure when you're done that the socket goes back in the bag and that the torque wrench is set back to 0 foot-pounds. If you leave it at 35 foot-pounds, you will ruin the wrench. When you're done, put the tools back where they came from, put the torque wrench back in its case, and put the T-handles back in their bag. The cutting cylinder is done now, so now you have to put the folder on top dead center. If you spin the folder around, you'll see on the tucker blade assembly that one side of it has a pin sticking out and the other side does not. You want to have the side with the pin sticking out facing up. When you see that pin, if you look on the right-hand side of the folding cylinder, you will see a mark and an indicator. You want to spin the folding cylinder so that the indicator is about a centimeter above the mark. If you look on the front of the folder, you'll see a little window on the left side. That window is to help you line up top dead center. The mark on the left is where you want it to be, and the indicator on the right is where the folder is actually at. And if you look here, you'll see that the indicator is actually just a little bit high. You can grab the folding cylinder and move it to line this up. One thing that will affect top dead center is the lap wheel. For the folder to be on top dead center, you have to have the lap also on 0. With the lap on 0 and the folder where it was supposed to be, it should now be on top dead center. You can go around behind the folder and find the wheel that changes it from straight to collect. There's a bolt that holds this wheel in place, so the first thing you have to do is loosen that bolt, then drop the lock to the side. Grab the wheel and push it in. If this wheel does not push in, then the folder is not on top dead center. If you look at the top of the wheel, you're going to see a mark, and you spin it from straight all the way to collect. There is a switch at the top right. Rotate it to the collect side and then release it. Then pull the wheel out. When the wheel comes out, you should hear a slam. If you do not hear that, then it did not work properly. Push the wheel back in and then try to toggle it back to collect again. Once you've heard it, put the lock back on the wheel and tighten it back down until you hear the air repressurize. On the air logic, the straight to collect indicator should now be green. Reset the air logic and then reset the folder on the Gus. Finally, close up the doors on the folder, put the pry bar back in its drawer, and wind the hose for the air gun back up. So what did we do here? The first thing you have to know is that in straight mode, every time the cutting cylinder cuts, it makes a new copy. In collect mode, the pins grab the paper, the cutting cylinder cuts it off, but then the pins don't disengage. So it pulls the paper one full revolution around the folder and then lays it on top of the next set of paper. So you have twice as many pages, it just takes twice as long. In order to achieve this, the paper that goes on the inside of the product has to be slightly smaller than the paper that goes on the outside of the product. If it's not, then it would be sticking out. So when we change the spacer on the cutting block, we moved it so it's going to be cutting the first set slightly smaller than the second set. The second thing we did was when we pushed the Allen into the tucker blade, we were disengaging that tucker blade, so only one tucker blade moves for every revolution. And the third thing we did was we changed the cam. On older presses, you actually have to open up the cam door, unbolt a section of the cam, take it out, and then put in another cam that's designed for collect mode. That cam is going to change the timing on the pins so that the pins will hold the paper instead of letting go of the first sheet. The technology has improved on the folder, so what we have now is a 2-speed cam. The second speed will do the same thing, but it's going to do it much slower. The pins will stay out for a full revolution of the folding cylinder and then release just after the second fold. And all that's done is with that simple toggle next to the wheel. Once the folder is changed over, you also have to change over the conveyor because the timing will be different. To do that, press the stop in on the conveyor, then switch the conveyor to 2 to 1. That means it will be traveling at half speed. And then in the quiet room, also change that toggle from straight to collect. Once you pull the stop out of the conveyor and turn the safe off of the folder, you are done. To get access to the front of the folder where the rubbers are, there's a door in the front with a handle on it. Grab the handle and just give it a strong tug, lift it up, and then put the latch underneath it to hold it there. You'll need a 50-pound Allen torque T-handle for changing out the pins. You'll need a pry bar, a rubber mallet, a used cutting rubber, and the grease gun. When the folder is up like this, you can see in through the bands the tucker blade assembly, and if you look on the right-hand side, you'll see 2 grease zerks. Lock the grease gun onto the zerks, and then give it 3 squeezes per zerk. There's 2 ways to remove a cutting rubber. The first way is to remove the bolts from the locking plate, then pull it out with the cutting rubber, then flip the cutting rubber or put a new one in and lock the plate back down. That's considered the hard way, so we're going to talk about what is considered the easy way. Put the pry bar on the left side of the cutting rubber and pop it out. If you look on the side of a cutting rubber, you'll notice that it is rectangular. That means you have 4 sides. Check all 4 sides to see if they're used, and if they are used, then you'll need a new cutting rubber. If not, just flip it to a non-used side and then you can hammer it back in. Start by lining the cutting rubber back up as flat as you can and then tap it in with the rubber mallet. Something you want to pay close attention to is that the pins are directly beneath the cutting rubber, so if you strike them with the mallet, you will break them off. It's best to start with the cutting rubber as far to the left as you can get it because it will move to the right as you hammer it in. You do not have to change out the cutting rubbers every time you look at it. A good gauge is that if it has just a thin line going across it, then you're fine, but if it's starting to get spread out or if it has 2 lines because it just ran in collect mode, you want to change that cutting rubber. Then take the spare cutting rubber, lay it on top, and then you'll have a spacer so you do not damage the pins. Then you can hammer the cutting rubber the rest of the way in. If you do change one cutting rubber, you have to change all 3. So spin the folder around until all 3 cutting rubbers are changed and that you've greased both sides of the tucker blade assembly. As you're doing this, check all the pins to see if they're bent, and if you do happen to break one off, then you'll have to change out the pin. The pins are basically nails, but they're specifically hardened for the folder, and you'll find them in the drawer in the quiet room. To change a pin out, grab the female torque T-handle, put it on top of the pin, and slide it down until it slides over the pin receiver. Then spin the T-handle to the left to loosen it up. Then grab the pin and the receiver and pull them both out. Pull the pin out of the receiver, and if the receiver is not damaged, you can reuse it. Put a new pin inside it and make sure that the squared off side of the receiver is on the same side as the tip of the pin. Then place this assembly back into the folder and then torque it down with the T-handle. When the T-handle clicks, that means that it's done. The last thing you have to do is lubricate it using the farvel. And the farvel is just a big container of grease with a handle on the right side that pumps the grease into the folder. At the bottom you'll see a gauge and a red plunger. The plunger changes which folder is being greased, and the indicator shows how much pressure is behind the grease going in. I'm doing it with the folder stopped just to demonstrate how it's done, but you want to do this with the folder running, otherwise it doesn't do anything. Grab the handle and push it back and forth until the gauge reads 100. You want to keep the gauge at 100 for approximately 30 seconds. If you go over 100 pounds, you could damage the folder or the farvel, so do not go over 100 pounds. So get it to 100 pounds, and then as the gauge drops, just keep pumping the handle to keep it at 100 pounds. After 30 seconds is expired, pull the red plunger out to do the other folder. Also pump it to 100 pounds for 30 seconds and then push the plunger back in. And then you're done. When you're running the folder, your main job is going to be aligning all the paper so that when the folder chops it off and sends it through the second fold, it looks like a book. It needs to be aligned up and down and left and right, and all of that is done above the folder. When you align the paper up and down, that is what we call heads. So you're moving the heads up and down. And one thing that you have to remember is that when you say the word retard, that is actually moving the image up. And when you say advance, that is moving the image down. To keep it simple, almost everybody says just move the heads up or move the heads down, but if somebody says advance, you need to know what they're saying. Advance means move the heads down. We're fortunate on this press because this is a shaftless press, which means that you can move the heads up and down simply by advancing or retarding the cylinders on the units themselves. The cylinders will stay synchronized to each other, but they will all move millimeters at a time, whichever direction you choose. If you look at the top of the Gus console, you'll see these 2 buttons that look like 3 webs. The button on the left moves all the webs on the left side of the press, and the button on the right moves all the webs on the right side of the press. And if you want to move them up and down, you use this column labeled unit comps. So that is the head compensation on the units. After the paper goes through the units, it goes through a series of pipes that are designed to keep the paper at an even tension as it's going through the press until it hits the first motorized roller called the drag roller or the RFB, or roller front of bar. You have the capacity to make this roller go faster or slower. If you are on the Gus console and you click on the folder, then click on the button to the right that says gain, you will see the folder drives gain screen. And from here you click on the drive that you want and you can increase it to 2.5%, which is the fastest, or 0, which is the normal speed. So if you find that the paper is too tight from that drag roller to the former board, you can increase the speed to give a little slack to the web from the drag to the former board. And if you notice that the paper from the drag roller to the former board is too loose, you can decrease the speed a bit. Most of the time you're going to be running these RFB speeds at 0. You will also notice that on these drag rollers you will find the drag slitter. If you go back to the bar stack screen, you will see a column that says slitter. Normally you would be able to move these slitters left and right. So if you looked at the product and you saw the slitter wasn't cutting in the correct place, you'd be able to move it a little bit. Unfortunately, due to an engineering flaw, these have been electronically disabled. The reason is because the drag roller and the slitter assembly are two different pieces that do not move at the same speed. They're not synchronized. So if you try to move it, it will only move one of them, and then you end up with the slitter riding on top of the drag roller. Then it destroys the roller, it destroys the slitter, and you lose a lead at best. On most presses you can move the slitter, on this press you do not. After the paper passes the drag roller, the next pipe it hits is called the turn sheet. So if you have to put a bar or a split in, that bar or split is going to S-wrap around the turn sheet. The turn sheet is a pipe roller that's on an assembly that can move. One thing you're going to notice about the turn sheet is that it moves very, very slow. So if you put in a large move, it's going to take several minutes to complete. This video has been sped up considerably to show you what it does, but it's important to know that if you put in the wrong number, it's going to take quite a while for you to get to the correct spot. Negative numbers will always make the paper slack up, and positive numbers will always make the paper tighten up. So if the press is stopped and you put in a positive number, it might tighten up to the point where it rips that lead out. In the bar stack screen, if you look at the column that says turn sheet, that is where you move this comp. In the event that the press is stopped and you do have to make a positive move, you have to first rip that lead, then make the move, and then stick the lead back in. After the turn sheet is the angle bar. This is the first place where you're going to start lining up the sheets left and right, or side to side. Back on the bar stack screen, you will see a column labeled angle bars upside and drive side. Each bar will move independently, so you have to make sure that you're doing the correct one. If the bar is moving to the up side, use the up side column, and if the bar is moving to the drive side, use the drive side column. A positive number will always move the angle bar to the drive side of the press, and a negative number will always move the angle bar to the operator's side of the press. And these angle bars also move very, very, very slow. You will notice on the side of the press near the angle bars are the motors that move them, and you will also notice that they have a bolt head on the end of them. If you need to move it manually, you can grab it or put a wrench on it and move it from here. After the paper passes the angle bar, it hits more dead pipes until it gets to the next motorized roller. The next motorized roller is called the RTF, or roller to former, and it is located directly behind the former board. The speed of the RTF can also be adjusted in the drive gains screen, and the RTF also has a slitter called the gang slitter. This slitter is fixed, it does not move, and next to it are the trolleys. The trolleys push the paper onto the RTF so that the RTF effectively pulls the paper to give it slack over the former board. There are 8 trolleys. Each of them has a number. Number 1 is on the operator's side and number 8 is on the drive side. It uses air pressure to push the trolleys onto the RTF, and that pressure is gauged in atmospheres. So 1 bar is 1 atmosphere. If you look at the gauge on the front, you'll see a dial, and if you turn that dial to the right, it will increase the pressure of the trolley. If you turn it to the left, it will decrease the pressure of the trolley. The more sheets that you have running over the RTF, the more pressure you want from the trolleys. While you're running the press, you may notice that the paper might be tight on one side and it might be flopping around on the other side. If that happens, then all you have to do is tighten up the trolleys on the side that's flopping, and it should tighten it up. You'll also notice that the trolleys are angled in such a way that it's going to be pulling the paper to one side or the other. So trolley number 1 is going to be trying to pull the paper to the operator side of the press, and trolley number 8 is going to be trying to pull the paper to the drive side of the press. It's designed to do this so it stretches the paper out so there won't be any wrinkles going over the former board. You can eliminate most of the problems that you're going to have with the mid board or the third high by having good trolley settings. If you're running a 4-page section, that means there's just going to be 1 sheet going across that part of the RTF. Then you want to have it at about 1.5 bar to 2 bar. If you have 8 pages, which means 2 sheets, then you want to have it at about 2 to 3 bar. And anything above that, you want to be looking at 3 to 4 bar. Keep in mind that the more pressure you have on it means that the more wear and tear you're going to have on the trolley, and it'll also increase the chances of ripping a sheet because the trolley can tear the paper. If the trolley gets damaged, sometimes it can get out of round and it will bounce. If that happens, that trolley needs to be replaced. After the paper passes the RTF, it's going to go over the former board. The former board is a triangle made out of metal, and as the paper runs over it, it creates what we call the first fold. It bends the paper over the left and right side and then sends it down. You may notice on the front of the former board that there's a bunch of grime all over it. That grime is a combination of paper dust and ink, and you you just need to clean that off every once in a while. One thing you can do to prevent that buildup is to turn on the air. Behind the former board is a handle. If you turn the handle so it's facing up and down, that opens up the valve for air to flow into the former board, and it pushes out holes on the side. That creates a pocket of air for the paper to float over the former board. That can create a problem though, because the paper as it floats around will not be tight, and it can create runnability problems. Most of the time we run the air at about half, sometimes off. Just keep in mind that with the air off, it is going to create a lot more grime, which means you need to clean the former boards more often. Below that are two rollers called RPF. That's roller point of former. Those are two dead rollers that guide the paper into the nips. These rollers are important because if they're too far out, the paper will be too loose, and if they're too far in, it will break the nose of the paper. The RPF rollers are adjusted by the dials on the front of the former board. The two dials on the right hand side adjust the right side RPF, and the two dials on the left adjust the left side RPF. The dials on top adjust the front, and the dials on bottom adjust the back. There are also indicators on the front and back of the former board, and the default settings for these are 4s on the front and 7s on the back. They're also marked with a red line. There's another slitter that goes in the middle of the former board called the tab slitter, or a tabloid slitter. If you run this, you may find that the paper is trying to run over the nose of the former board, and if that happens, you will have to push the front of the RPFs out a little bit. In front of the former boards, you'll see wheels with handles on them. If you grab the wheel and pull it out slightly, that will engage the wheel. If you move the wheel counterclockwise, it will move the former board to the left, and if you move it clockwise, it will move the former board to the right. This is effectively changing where the point is on the paper that's running down. And this is the second point where you're going to be adjusting the side to side of the final product. You can do this same thing electronically from the GUS. From the home screen, if you click on the folder in the center and then click on the button that says REG, directly underneath the former boards, you'll see the box to input your moves. After the paper travels past the RPF, it will then hit the nips. As it's hitting the nip, the first fold will be complete. The front of the fold, where the fold occurs, is called the nose, and the open end is called the tail. The nips are a large cylinder with knurled ends that grab the paper and pull it down. You can also adjust the speed of the nips in the drive gain screen, and they will be labeled with the letter M, so M3 through M16. Those are all nips. If you're standing beside the former boards, you'll see handles, and if you move those left or right, it will tighten or loosen the nips. These work opposite of bolts. If you turn it to the left, it will tighten the nip, and if you turn it to the right, it will loosen the nip. So remember, lefty tighty for the nips. This can also be adjusted electronically from the GUS. From the home screen, if you click on the folder and then click on nips at the bottom right, you'll see the nip gap control screen. The right side number is the nose of the nip, and the left side number is the tail of the nip. And you can move them to 0.01 of a millimeter. After the paper travels over the nips, it's going to go over the balloon comp, and this is a lot like the turn sheet in that it is a pipe roller on an assembly that will move. This is adjusted from the GUS. If you click on the folder, then click on the REG button, you'll see the drive side and operator side balloon comps. The two on the top are for the third high, and the two in the middle are for the mid boards. You may notice when you're grabbing the product that one section or balloon might be a little bit higher than the other one, and you can use these comps to adjust that. Then the paper goes over a few more rollers until it gathers into the collating set of nips. There's one collating set on the operator side that grabs all of the operator side balloons, and one on the drive side that does the same thing. And then from there, all the balloons go into the main set of nips. If you look underneath the two lower former boards, you're going to see what is called the cross associate. The cross associate does for the lower former boards what the balloon comps do for the upper former boards. In the event that the heads on the lower drive former board aren't lined up with those on the operator side former board, you can use the cross associate to compensate them. On most presses, the cross associate is two dead rollers with a handle that you can use to move them. On this press, it moves the collating set of nips for the drive and operator side former boards. It moves them side to side by putting the entire nipping assembly on a set of plates that move side to side. To move it, in the GUS, click on the folder, then click on the REG button, and then move the field that says cross associate. You can also move it manually if you have to by moving the wheel above the front of the folder. You have to grab the wheel, pull it out, and then crank it. In the event that there's a web break, if the press kept on running, it could wrap the paper around a cylinder and keep on wrapping until it breaks. To prevent that, we have web detectors, and these are sonic sensors that are constantly checking to see if there's a web underneath it. In the event there's a web break, it will send a signal back to the server, and that will shut the press down. If you click on the folder and then click on the button that looks like a broken sheet of paper, you'll see the web detectors for the units. Click on the unit, and then you can see which web detectors are active and which ones are inactive. You can also turn them on and off for the operator side or the drive side to account for the web that's going through it. Back on the folder screen, if you click on the button that looks like a broken web with the letters F1 above it, that's the web detectors for the folder. And these web detectors are checking the balloons. On the back of the lower firmware board, you're going to see these 3 tubes. They're connected to a vacuum. The vacuum is designed to pull out whatever paper dust or shreds of paper that the press might create as it's running. These 3 tubes are underneath the slitters that are going to be cutting the paper as it goes over the firmware board. If you ever run that slitter, then you also want to run that vacuum. There's a plate that goes through the tube. If you push the plate into the tube, it will cut off that vacuum. If you pull it out, it will open up that vacuum. Even with that vacuum, there's still going to be paper dust, and what we call spaghetti is going to develop around the press. Spaghetti is long strings of paper. Most of the time that spaghetti is going to collect around the nips. Whenever you see spaghetti wrapping around the nips while the press is stopped, you want to grab the spaghetti and rip it off. You also want to check all the pipes and nips to make sure that they're free of grime. A lump of ink on a pipe roller is going to bubble the paper as it goes over it. If the bubble gets too tall, it could rip the paper, and with that lump of ink, it could also pull the paper tighter on that side. The cleaner everything is, the better it runs, and the better that the press runs, the better of a folder operator you are. So it is in your best interest to check everything and make sure that it's clean. Next, we're going to talk about setup. If you ask any folder operator, they will all tell you that 90% of running the press is a good setup. So you want to do a good setup and then double check everything. The very first thing you do is when you walk into the quiet room, you're going to see a box. That turns on the ink and water. So turn on the Beck water system and turn on the ink system. Then find out which folder you're going to be running. As you're standing in the quiet room, you're going to see another box in the back, and that is for the conveyor system. If you're running the drive side folder, then you need to drop the conveyor. If you're running the operator side folder, then you need to raise the conveyor. Make sure that it's set to straight if you're running a straight run, and collect if you're running a collect run. Outside the quiet room, check the conveyor out there to make sure that it's set to straight or collect, and then raise or lower the table depending on the size of the product. The larger the product, the lower you want the table, and to move it, there's a wheel on the side. You can see the indicator next to it. That indicates the number of millimeters between the table and the grippers. Next, go to your console, hit the folder, then hit the Unit HYDR, that's Unit Hydraulics button, and you want to turn on the hydraulics for the side of the press that you're using. So if you're only using the left side of the press, turn on the left hydraulics. If you're using both sides of the press, turn on both hydraulics. Check the job to make sure that the correct job is loaded. Do that by hitting the job button at the top center of the screen. And then if you look in the middle, you'll see last activated in position program. Read that and make sure that it is the correct product. If it is not, hit the position button at the right side and put in the number that corresponds to the correct product on the left. Hit OK and wait for the green bar to select it, then hit activate and OK. When it says ready for presetting, hit the preset button at the top left and then hit start. When it says presetting finished, you can start setting up the rest of the press. There's a lot of buttons on here and you don't need to know what they all are right now. The ones that are important are the drives, gain, nips, register, comps, web detectors, and then finally the reel stands. So those are 6 sections that we're going to be looking at for doing any setup. I also do them in that order. So let's start looking at the drives. The drives is in the center left. It's a button with an M that has an icon that looks like a pair of vice grips, and those are the drives connecting. And that'll bring up the folder drive select screen. I'm going to be using this layout example as our setup. It is a 46-page product. The first section is 10 pages, then 8, 8, 8, and 12. On the left side of the press, we're running towers 2, 3, and 5. On the folder drive select screen, you can see on the left side that there is L1 through L6. Those are the drive rollers, or the RFBs. L6 is at the very top, so tower 2 is going to be running through L6. L5 is going to be tower 3, and L1 is going to be tower 5. On the right side of the press, we're running towers 6, 7, and 8. Tower 6 is R1. Tower 7 is R3, and Tower 8 is R4. You want to make sure that all of those drives are selected, so if they are not green, you just click on it and hit OK, and it will select that drive. In the center of the drive select screen, you can see the RTFs and the NIPs. There's 4 RTFs. You can see on the layout we're going to be running all 3 levels, so we're going to need all the RTFs in. Tower 2 is going to the third high and barred to the drive. So we need to have the third high RTF and the drive side nips on. The third high also has a second pair of nips, and you need to make sure that those are on as well. And anytime you're running the second or third high, you need to make sure you have the skip slitter on. Towers 3 and 5 are both going to the midboard straight, so we need to have the midboard RTF and both of those nips on as well. Towers 6, 7, and 8 are all going straight to the lower board, so we need need to have those two RTFs in, and then both nips for those lower boards. You always need to have the collating set in if you're running any of those former boards. And we're running the operator side folder, so we need the operator side main, and we need to have the operator side folder engaged. Next, we need to look at gains, or the speed of the driven rollers. Now this is where things get interesting, because each folder operator has run into problems that they've been able to solve in certain ways. So you've seen all the different things that we have on the press that you can use. They're all just different tools for solving different problems. And this is one set of tools that you can use to solve a set of problems. And what one folder operator believes is the correct way to set it, another folder operator is going to say is wrong. So this is where we get into what I call folder operator theory. For example, if you take a sheet of paper and give it an S-wrap, so that means it goes over one roller and then underneath another roller. If you do that, it's going to make the paper straighter between that set of pipes and the next set of pipes. That type of thing is usually done right before an RTF. And it's done to make the paper straight so that when it goes over the RTF and over the former board, everything is nice and straight. Now when I saw it, what I believed was it was taking the paper and slowing it down, because it was using the friction of the paper to push the pipe rollers. So the paper, as it was moving, was losing energy and transferring that to the pipe rollers, so it would then be slower, forcing the RTF to pull it tighter, and that would pull the paper tight and straight. I was talking about this to another folder operator, and what they believed is that was when the paper goes over those two pipes, because those pipes are already spinning, it is in fact pushing the paper and throwing it into the RTF, and that's what causes it to be straight. Now, I could be right and he could be wrong, or he could be right and I could be wrong. Now, I'm going to tell you what I believe based on what I've seen and what I know, but everything I tell you, you want to keep an open mind to, and if somebody else tells you something else, listen to them too. Then use all of the knowledge to make a decision that makes sense to you. So back to the gain screen. The default for all of the RFBs is 0.50. That means it's going to be running a 0.5% faster than the units. Now we found that when we do that, it tends to create a lot of slack on the webs going from the drag to the former, so we turn them all down to 0. Now you may find that some of these leads are running tight, so you might want to increase the gain slightly. Ones that I find that usually run tight are Tower 2, so that'll be L6, Tower 9, which is R6, and Tower 4 CD level, which is L3. From time to time, I will run those at about 0.5, maybe 1.0 if it's really tight, especially on half webs because they are fragile. The default on the RTF is 0.60. Here's what you need to know about the speed of the RTFs and the nips. On most presses, the nips gradually get larger as they go down. That means the circumference of the nip cylinder gets larger. That means that for every rotation, it pulls more paper. Now that doesn't happen on this press. This is all done electronically. So if you want there to be any increase in speed, you have to do it here. So they have the default RTF speed at 0.6 and the default nip speed at 0.35. Now when I look at that, what I see is that it's going to be throwing the paper over the former board and then pulling it tight across the nips, and that's going to create a bubble over the former board. Now that's okay, but running these gains I find makes too much of a bubble, and that creates a lousy product. The nips are fine at 0.35, but I turn all the RTFs to 0.4. All the RTFs except for RTF1, and I leave that one at the default of 0.6. That way as the web goes over the first RTF that it hits, which is RTF2, it's going a little slower, and then when it hits RTF1, it pulls it tighter. That makes a tight web going over the former boards. So now for the lower sets of nips. The collating sets of nips, I want to have those a little bit faster, because I want to have them pulling the balloons tight so that they're straight before they get to the folder. I run both M7 and M6 at 0.7. Because I'm running those so fast, I also increase the speed of the lower former board nips, which are M8 and M9, to about 0.5. That way it's a more gradual increase from there to the collating set. Then I'll leave the main set of nips, which is M5 at 0.95, which is the default. So that way it is a gradual increase of 0.5 to 0.7 to 0.95. And that way it just keeps on getting a little bit tighter all the way until it gets to the final set and then goes into the folder. That's the way I do it. I can tell you the way that other people do it. They all also put the RFBs at 0, and they leave all of the RTF and nip gains at the default except for M5, the main, which they'll raise to as much as 1.5. So it's just a nice slow speed all the way to the main, and then the main pulls it all straight. And what that can actually tell you is the amount of play that you have with this tool. And that's really how you need to look at this. It's nothing but a tool to help you solve problems. So if you're running the press and you're running into a problem, you can use this to solve it. Next, we're going to look at the nips, which is at the lower right side of the folder screen. Now we already know that every sheet is about 0.04 millimeters. That means that every page, which is just one side of a sheet, is 0.02 millimeters. So let's start at the top and work our way down. The third high drive side is just tower 2. That's an 8-page section. 8 pages times 0.02 is 0.16. So set the nose to 0.16 and the tail to 0.16. The mid drive board is also 8 pages, so both of those go to 0.16. The mid op is also 8 pages, so both of those go to 0.16. The lower drive board is 10 pages, so that goes to 0.20. And the lower op board is 12 pages, so that goes to 0.24. We always leave the outside third high set wide open, so the paper just runs over it and those nips guided through. And from here you have to start visualizing where the webs are going. So for the collating set on the operator side, that's going to have the lower op board and both mid boards running into it. So that's going to have 2 8-pagers and a 12-pager. That makes 28 pages total, so 28 is 0.56. The drive collating set is going to have the lower drive board and the third high. So that's a 10-pager and an 8-pager. That's 18 pages, so that will be 0.36. Total page count is always at the top right of the layout, and that'll be what the main is set to. That's 46 pages, so it will be 0.92. And if you want to double check your math, take the main number, subtract one of the collating sets, and that should give you the other collating set. If the math doesn't work out right, then you did something wrong. This is going to give you your default settings for your nips, but it's not always going to be perfect. These settings can go out of calibration. So the way to check to see if your numbers are correct is when the press is hot, you go up and you actually look at what the nips are doing to the paper. If you look at the paper, there should be small little indentations in the sides of the paper where the nips were pinching it. And if you run your fingers across them, you should be able to just barely feel them. And the best way to refine what you're doing is what we call a slip sheet. That's where you take a single sheet of paper and run it over the paper through the nips and then see what the indentation looks like on that sheet of paper. If you can just barely see them, then it's perfect. If you can't, then you need to tighten it down a little bit and try it again. To tighten it, just turn that little wheel that sets the nips to the left a little bit. Lefty tighty, righty loosey. Next, we're going to be going into the folder register button. The first thing to check is the second fold, and keep in mind that this also can go out of calibration. By default, this is set for 30-pound paper. Now, if you look at the wheel on the front of the folder, you're going to see that it has an indicator that shows 32, 30, and 28-pound paper settings. We were running 28-pound paper, which is 45 gram, but now we're running 40-gram paper, which is 24-pound paper. So the weight of paper we're using is not even on this indicator. It's so light. What that means is you need to set the second fold to be tighter than what the default is. A good rule of thumb is for a large product, set it about 5 pages under. The smaller the product, the closer you want to set it to the actual number. While you're here, you should also set your lap. So if you don't know what your lap is, ask what the lap is supposed to be and then set it accordingly. You can also set your pins. It's best to start with a bit more pin than you need and then take some of the pin off while you're running. And then finally the bands. There is a mathematical calculation for determining what the bands are supposed to be, and that is 6 minus parentheses the page count divided by 26.7 parentheses. The reason we get that is because the folder goes up to 160 pages and the bands go up to 6. The idea is you want to have the outside sheet of paper to always be in the exact same spot, and the bands are going to be what puts it there. So if you divide 160 by 6, you get 26.7. That means for every one band, you can have 26.7 pages. So if you take the page count, which is 46, and you divide that by 26.7, you'll end up with 1.7. 6 minus 1.7 is 4.3. That means that a proper band setup for a 46-page product is 4.3. Now you will find that if you actually run 4.3, it will be way too loose. You'll have paper going all over the place. So 4.3 is not correct, and that is mostly due to the fact that we're running such a light poundage of paper. What I've been using is a formula that my old press room manager gave me, which is actually for a larger folder with a larger band. So it's a 192-page folder with a 7mm extending band. So the formula I use is 7 minus parentheses the page count divided by 27.4 parentheses, and this formula is written on the top of the monitor for both of the folder consoles. So 46 divided by 27.4 is 1.6. 7 minus 1.6 is 5.4. This is a considerably higher band, but it will run perfectly fine with this product. When you start looking at the balloon comps, you need to start looking at the folder Bible. That's a 3-ring binder with all of our notes. If you open it up to the second page, you're going to see the folder balloon comps. These comps are going to be different if you're running the operator side folder or the drive side folder, so make sure you're looking at the correct folder. For this layout, all the balloons are going inside. That means that for the lower former boards, all the balloons are going to be collecting between the two lower former boards. If they were going outside, then you have to use the outside comps. These are all inside, so use the inside comps in the Bible. And finally in this screen, set the cross associate. The former board side lay, you're not really going to be adjusting here. That's something that you're going to be adjusting as soon as the press fires up. The number of pages and the locations of the pages on the former boards are going to affect the former board side lay. So the best way to find out what numbers you need for this are to start the press, see how it looks, and then adjust accordingly. Next, we're going to be adjusting the bar stacks. These numbers are also going to be in the Bible. If you're looking at the left bar stack and you look at the left side, you'll see the RFB designation, so 1, 2, 3, 4, 5, 6. And then just next to that, you'll see the tower that is running through it. You want to make sure that you double check this because every once in a while, when the supervisor creates the imposition, this will be in the wrong spot. So you can see where it says 2 and 2. If that said 0 and 0 and it said 2 and 2 next to L5, and you would have to click on those 2s, hit 0, then hit enter, then go up next to L6 and then click on those, hit 2, and then hit enter. Otherwise, you'll be adjusting the comp and nothing will happen. So we can see that 2 is running to the third high, so we use the third high straight comp. And it's also got a bar and it's barring to the drive, so you use the third high bar to the drive comp. Unit 3 is running to the midboard, so use the midboard straight comp. And tower 5 is also running to the midboard, so use the midboard straight comp. When you're done, hit the bar stack right button. And towers 6, 7, and 8 are all going to the lower board, so use the lower board straight comps. From the folder screen, click on the folder web detectors and then turn on the third high web detectors. There's 2 of them, make sure you turn both of them on. Then turn on the mid drive board web detector and the mid operator side web detector. If the web detectors don't go green, click on the reset button and then click OK. Then click back and hit the unit web detector button. Tower 7 on this layout is a 7/8 to the drive. That means you need to turn off the operator side web detectors. That way if the web wanders off too far to the drive, it won't shut the press down. And tower 8 is a 3/4 op. That means you need to turn off the drive side web detectors. All the other webs are full, so you can leave the remainder of the web detectors on. And finally, check the reel stands. If you look on the bottom right, you'll see the manual brake control buttons on and off. They kind of work. You have to hit them over and over and over and over for them to actually go on. It's a lot easier for the people in the rear room to turn it on and off. But you'll see here that it is a light green. That means that it's not on. And if you hit the on button and hit OK, hopefully it will go to dark green, and that means that you have brakes. You want to make sure before you start the press up that you do have brakes. If you don't, you risk losing the web. Look at the start tension and running tension. The defaults for running tension, if you're running a half roll, it's 65, a 3/4 roll is 75, and a full roll is 80. Now this again is for the 28-pound paper, and because we're running a much lighter paper, we have to run a much lighter tension, otherwise it's going to rip the paper out. What we've been using for a while is 50 pounds of running tension for a half roll, 60 for a 3/4 roll, and 70 for a full roll. The start tensions are always at 25, but I also bring those down correspondingly. 10 for a half roll, 15 for a 3/4 roll, and 20 for a full roll. Check the reel width and position. If it's a full roll, the NS, NC, FC, and FS should all be dark green. If it's a 3/4 to the drive, then the NS will be white. And if it's a 3/4 to the op, then the FS will be light. Make sure that it's set for the correct web size. If you look on the left, you'll see copies remaining. To start the press up from 0, you want to have at least 700 copies. If you have less than 700 copies, then you want to tell the rear room to do a changeover. And at the top left, you're going to see the tower that it's going to be running through. If the tower is not correct, then click on the number and then put in the correct tower, and make sure you do that for the top and bottom. That's all you have to do to electronically set up the press. From this point, walk out and make sure that all the webs are going to the correct place. Then you can make the press hot, and then take a look around and see if there's any problems. Check the nips to make sure they're all pulling right, and it's extremely important to check all the webs to make sure they're going over the correct pipes. If they're not going over the correct pipes, then it will affect your comps and you will have bad heads when you start the press up. Check the slitters to make sure that the correct slitters are running. You want to have only one set per level. For this layout, I would run the gang slitter on the lower former board and the gang slitter on the mid board, and the third eye is going to be using the drag because of the angle bar. Check the air behind the former boards. If you have straight sheets like this, you can have the air cracked on, but if there was ever a dinky on the bottom, then you would want to turn the air off because it would make that dinky float around. The lower drive board is an example because it's a 10 pager with a dinky on the bottom, but because we're running the gang, it's not going to be a problem. It's going to hold that sheet there the whole time. Running the air off is more important on the mid boards because that's where most of the problems happen. For this layout on the trolleys, I would put trolley 1, 2, 3, and 4 all at 3 bar. Trolley 5 I would run off. The reason I would run that one off is because if you have both trolleys 4 and 5 on, it will pinch in the center, and that pinch could push the paper underneath the slitter. If the paper is not being stretched across that slitter, the slitter cannot cut it, and then it will tear out the lead. Then I would also put trolleys 6, 7, and 8 on 3 bar. When you're done up here and you feel that everything is good above the folder, go back down, make sure that everything is still pulling straight, and then you need to walk off the press. Make sure that nobody is hanging plates because this will throw in the cylinders. Then go back to the home screen and then hit the pre-inking button. That's the button at the top right with the black, yellow, red, and blue. Then hit activate and OK. Wait for the activate button to go green. Then hit activate and OK again. Make the press hot by hitting the button on the right side of the console that looks like a solid arrow moving to the right. You'll hear the warning alarms go. When they stop, hit the button again. Let the press walk for a little bit and then hit the impression button. That's the button that looks like a circle with a line underneath it. It's supposed to be representing the cylinder pressing onto the paper. If there's any ink on the cylinders, it's then going to put that on the paper. The paper is going to take it away so that you're going to have nice clean cylinders to start out with. And you want to get that done and out of the way before it's time to actually start the press. And then do a pre-ink. To do that, go back to the pre-ink button, then hit activate OK, wait for the activate button to go green, and then hit start and OK. This is going to put the press in pre-inking mode. All the webs are going to be walking slowly, and there is a small danger of water and ink getting thrown onto the webs and the webs breaking out. So while this is happening, you should be out looking at the webs, watching them, and making sure that nothing's about to happen. Keep in mind that when you do this, there is going to be a shot of ink that's going to be fired into each module. You do not want to do it a second time because there is a danger that you will overflow one of the modules. When this is done, hit the button at the top left that looks like a square, which is supposed to represent the unit, then the folder designation, and then a triangle, which is supposed to represent the folder. Then at the bottom in the middle, hit the start button under disengaging, and that will disengage all the units. From this point you're done, you should help hanging plates or do whatever else needs to be done and until the press is ready to go. Eventually it's going to come time to run the press. First thing you're going to need is a piece of paper, and this is where you're going to write all the start and stop times. Every time the press starts up, you write down the time, and every time the press stops, you write down the time and why you had to stop. If that was simply the end of the run, you just write end. You're going to have 2 radios. One's going to be on Charlie channel. You use that to talk to your rear room, and the other one is going to be on supervisor channel. The supervisor channel radio you use to talk to the packaging department. Throw in the units by hitting the pre-ink button and then hitting activate OK. When it goes green, hit activate OK again. Start the job by hitting the PMS button and then hitting job start OK. When all the units are in, make the press hot and let it walk for a little bit at this speed, just a few revolutions to make sure that nothing is sticking. Then throw the impressions on. With the impressions on, walk the press for a few more revolutions and then increase the speed of the press to about 600. This is just to make sure that everything is still pulling tight. Let it walk a few more revolutions and then increase the speed to 1200. If everything looks good, increase the speed to 7200 and the press will automatically throw on the ink and water. When the press is going up to 7200, call over to packaging and let them know that you're coming up. Packaging Charlie, press is coming up with the main. When the press gets up to speed and the ink starts laying down, the first couple minutes are going to be critical. The longer it takes you to get everything lined up, the larger the gap is going to be. You want to get everything lined up and even as quickly as possible. The unit operator is going to grab a copy for you and thumb through it just to make sure there aren't any problems. If there are, then you have to fix them. Here you can see Tower 6 is good, but Tower 7 is a little bit low. So I go to the unit comp screen and bring up the heads about 5 points. Everything else looks good until I get to Tower 5. Tower 5 is a little bit high, so I bring those heads down about 5 points. When I get to Unit 7 on the other side, I can see that the margin on the Speedia is pretty close, so I want to bring 7 to the op a little bit. So I go to Reel 7, go to the Reel side lay alignment, and you can see the number that it's at is negative 1.5, and for some reason the number it's trying to go to is 1.5. So I put in a negative 4.5, and the new number it's going to try to go to is negative 3. So it's going to try to go to the op 1.5. Maybe a little more, so I put another 1 point to the op. On the next copy, the margin on Tower 6 looks like it's a little far to the drive, so I bring that to the op 1.5. Tower 7 still looks a little low, so I bring that up another 5. And the side lay on 7 is still too far to the drive, so I bring that back to the op about 3 more mil. The margin on 8 is also a little too far to the drive, so I bring that back to the op 2 mil. The heads on Tower 2 have fallen a bit, so I bring that up 8 mil. And the bar on 2 is a little bit lower than the straight sheet, so I bring that one up 1 mil. Everything's looking good. The supervisor gaps it, so you grab the supervisor radio and let packaging know that good copy is on the way. Packaging, good copy coming on, Charlie. On the third copy, I'm checking the side alignment, and on the A section, everything looks good, but on the B section, it looks like the bar is hanging out to the drive a little bit too far. So go to the angle bar, hit -3, and anytime you move the angle bar, it's also going to move the heads a little bit. So if I move the angle bar -3, I'm going to move the turn sheet up 3. Anytime you move a drive side angle bar, you move the turn sheet the opposite way. Anytime you move an op side angle bar, you move the turn sheet the same way. This bar is going to the drive, so you use an opposite move on the turn sheet. The mid-drive board, which is the Sun section, looks lined up. The mid-op board, which is the Charlie section, looks lined up. And the D section, which is the lower op board, looks lined up. Everything looks good, so it's time to start speeding the press up. Early on in the run, speed matters because once you get over about 20,000 on the speed, that's going to give you a new curve on the water, which is going to affect the ink laydown and make everything look better. And when that looks better, it's also going to help out the QTI to make the registration pull in. So you want to get up to speed as soon as possible. Packaging department is going to call back and tell you what the gap was.
Second pressure got the 628, 628.
So that's how many copies you killed from the time you started until the time that you had good copy. You call back to confirm what the number was and then write it down. Copy that, 628. Thank you. It's more important for me to get the speed of the press up, and as I'm increasing the speed of the press, I'm also looking very carefully at the paper coming through the folder. You want to make sure that nothing's flopping around and nothing's sliding around. Most of the time when there's a problem on the press or something occurring, it's going to happen during a speed change. You're going to be paying extra special attention whenever you're changing the speed of the press. So now I've gotten above 20,000 and I can write down the gap. The speed of the press is also going to change the heads because it's going to be pulling and stretching the paper differently. So I grab a copy and I see that the heads on Tower 6 have dropped a bit. So I bring them up about 5 mil. The bar on 2 has moved up a bit and it's also pulled to the op. So I bring the heads down and I push it to the drive. Tower 5 has dropped a little bit. It's not bad, but you can see that the pins are in the image area, so you want to bring the heads up a little bit. All in all, it looked pretty good, so I'm going to start speeding the press up again. Got up to about 27,000, and I'm going to grab another copy. You can see that the bar has moved around a little bit more, so that's making me think that I have something too loose. Looking at the nips on the nose side, everything looks good and tight, but on the tail side, you cannot see any marks at all, so I'm going to tighten down the nips on the open side. I'm also going to move the bar a little bit more to the drive and bring down the turn sheet to compensate. In the D section, the Spadia has a little bit more margin than I want it to, so I'm going to kick that back to the drive about 2 mil. You can see here that reel 2 has lit up yellow. That means that there's a paster in cycle and the press now has a safe on, meaning I cannot speed it up. Looking at the gust, there's also a yellow mark that says press speed locked. All you can do is wait for the paster to finish and then you can speed the press up. Even if you hit the plus button, it does not work. Looking out at the conveyor, I'm noticing that it's dropping too many copies, so I'm putting on my hearing protection, going out and lower the table a little bit. The table will need to be adjusted as you speed up. This is also giving the product enough time to settle, so all the webs are now going about the same speed, so it's time to check another copy. Tower 6 is a little bit too far to the drive still, so I'm going to kick that back to the op. The Baker section is finally starting to look good. The Sun and Charlie sections look good, and as I'm looking at the D section, I find a little bit of red scum. If and when you see a problem like this, you want to call that out to the unit operator so that they know it's happening. Get a little red on 7 dog left side. Yep. That way if they're concentrating on something else, we'll have minimum bad copies going out. So I grab another copy and you can hear the printer go off. That means that Tower 2 has finished pasting. And just like a unit operator, anytime something happens, you want to give it about 10 seconds before you check that next copy. So I take a few seconds and I run through the copy just to see if the heads are all still good. Most commonly when a paster goes through, it's going to change the margin. So you want to check the margin first and also check the heads. And I can see here that it moved to the op a little bit, so I'm going to kick that back to the drive. The heads on 7 have raised up a bit, so I'm going to kick that back down. Call out the yellow scum on 1 Baker. Little yellow on 1 Baker left side. And it looks like the head shot up a little bit on 2, so I'm going to bring that down. I spot the red scum on D5 again, but I probably just grabbed it too early, so I'm going to let that one go. While I was doing that, Tower 7 pasted off, so on the next copy I want to check Tower 7 on the margins. In the A section it looks good, but when I move back to the Spadia, I can see that it's pretty close, so I want to move that to the op a little bit just to give that some leeway. I still can't speed the press up because now Tower 3 is in cycle. I'm going to give it time to paste because that's going to give time for all the moves that I put in to acclimate and for the press to settle. 3 pastes off, wait 10 seconds, grab a copy. Always check the drive side of a sheet and the operator side of a sheet every time it pastes, because every once in a while you will get a narrow roll. This one looks a little narrow, so I'm going to grab another copy to make sure that it wasn't a fluke. Sometimes rolls do start out narrow and then get wider as they go. It looks fairly good now and there's no pasters in cycle, so it's time to speed the press up a little more. The goal speed is 32,500 on the screen. That's 32,500 collect, which means we'll actually be running at 65,000 copies per hour. Again, as you're doing this, watch the speed, but also watch the press. In the event that anything anything goes wacky, just stop speeding the press up. On the conveyor I can spot some red, so I call that out.
Getting some red on one able.
On the next copy everything looks mediocre but passable, and I'm going to count that to just having sped the press up. Something I'm looking at with the baker section is that on some pages the heads look too high, and on the other side of the same page the head looks just right. This can be accounted to either plate making in the way that they're laying the pages down on the plate, or it could also be the unit synchronization. I'm also looking at the bar and it looks like it's still too far to the up, so I'm going to move that to the drive a little bit more and move the turn sheet down a little bit to compensate. Unit 3 looks just barely a little bit too high, so I'm going to kick that down about 1 mil. And in the D section, Tower 8 looks like it's too far to the up, so I'm going to kick that to the drive. Now, I didn't see Tower 8 paced off, so I don't know why that's hanging out now. One thing you can do is you can check the printer because it does have a log of everything that happens. So if there's a paster that goes off, it is going to log that on the printer. And there is no log, so I don't know why I did it. There's now some red scum on the front page of the baker section.
Got some red on one baker left side still.
At this point, the packaging department calls out red scum on the front page, and they call it the number of 200. That means they killed 200 copies for red scum on the front page. You grab the radio and let them know that you heard them.
Copy that, 200, thank you.
Write down the number they killed and why. Then hit the PMS button and enter that number into the waste. That will subtract 200 from our net copies and add 200 to our waste. That way when we bring the press down, it will account for those 200 copies that they killed. There's now about 10,000 copies up, so it's time to grab a keeper copy. Every 10,000 copies, you need to grab 2 copies. That'll be a high and a low, and write how many copies were off when you grabbed it. That way there will be a physical log of what the copies look like throughout the run. What I'm doing at this point is similar to what I did when I was running units, where I would check the first section and then throw the copy away, then check the second section. And the reason I do that is to give it time to settle. But when I'm on the folder, I check the side lay and the margin on one copy, then throw it away, and then check the heads on the next copy. And I just do that back and forth and back and forth. It looks like the bar on 2 moved back to the op a little bit, so I'm going to push that back to the drive a little more. If you check a copy and you're not sure if the heads need to go up or down, it's best to check both sides of the sheet. So here I'm looking at Tower 7 in the A section and in the D section. And it looks like it needs to go down a little bit in both, so I'm going to kick that down a little bit. And Unit 8 needs to go up a little bit in both sections, so I'm going to kick that up a little bit. And it looks like 8 is still sticking out a little bit too far in the D section, so I'm going to check the A section and see how it looks in there. And it looks like it could push to the drive a little bit, so I'll do that. And it turns out it did not take my last move, so I'm just going to kick it 1 more to the drive than my original 2. So it's going to move a total of 3 points to the drive. You can see on here where the outline is flashing blue and green. That means it's trying to move, it's thinking about moving, but it's not actually moving yet. So I'm going to watch it and see if it actually moves this time. And eventually it does. You can see the -1 on top now matches the -1 on the bottom. And it now looks better. Problem with moving that too far to the drive though is that it might be cutting off the diamonds and affecting the registration. So I checked the QTI on Tower 8 to see if it's reading. It is not reading, so I am cutting off the diamonds, so I'm going to move that back to the up 2 mil. So in a matter of what you're willing to settle for, it's way better to have a sheet sticking out a couple millimeters than it is to have bad registration. And the bar on Tower 2 is still a little bit too far to the up, so I'm going to move that to the drive even more. Right here I can see a little offset, so that's where the ink on one image is rubbing off on the sheet of paper on the other side. What causes that is 2 things. That's too much ink on the paper, and it's also that the second fold is too tight. What you can do is you can open up that second fold a little bit to relieve some of the pressure. So grab the hearing protection and head out to the second fold. This maneuver is something you definitely do not want to do from the gust, because when you put an electronic move into the second fold, it has been known to do a move that is way larger than you intended. And if you open up the second fold too much, it won't pull the copies down properly, and you might end up shutting the press down. So this is something you definitely want to do manually and carefully. The best way to do this is to squat down and put your hand on the wheel, and then lean as far forward as you can so you can see the copies coming out. Rotate the wheel clockwise very, very, very slowly to open it up, and if you start seeing the copies twist as they're coming out, you want to tighten the second fold back up. Now here I'm just loosening it up a little bit, and then I check the copies to see if they've still got that offset, and it looks like it has gotten a lot better. You will, however, start to notice that as you loosen that up, the quality of the edges of the paper is going to get worse. And that is mostly on account of the cheek woods on the cutting block having to do more of the work instead of the second fold pulling it down, pulling it tight so that the knife block can chop a clean cut. But it is better to have a good looking image than it is to have pretty looking edges. As the papers are coming out, I am noticing that they are slightly crooked, so I'm going to mess with the cog belt. I loosen up the nut and start twisting the wheel to the right to push the cog belt down onto the paper. And it's not really getting a heck of a lot better. better, so I'm going to try and go the other way. And that's not really working either, so I'm going to put it about back where I started with and just leave it. While you're here, grab whatever trash the conveyor threw out and throw it away. There's now about 20,000 copies off, so grab 2 copies for the keepers. Now, something weird in this run happened at about 30,000 copies. I started seeing a wrinkle appear on one able. Something I try first is to drop the gain on RTF2 so that it pulls it tighter over RTF1 and hopefully pulls that wrinkle out. That didn't work, so I go up the stairs and I look at the web as it's going over the RTF, and you can see the wrinkle appearing in the web before it gets to the RTF. So the next thing I try is to increase the pressure on trolley number 8 to try and pull it harder to the drive side. Then I pick up trolley number 7 to stop it from pulling to the op. The idea is to stretch out the paper between trolley 6 and trolley 8. Now there's 2 RTFs on the lower board, so you have to do the same thing to both sets of trolleys. And that doesn't really work, it just kind of changes the position of the wrinkles. So I start picking up trolley 5, and it's not really working. You can see looking at the web that it's just wrinkling all over on this drive board. So the next thing I see is that the sheet, as it's pulling over the operator side, is nice and flat. It's just on the drive side where it's wobbling around. So what I'm picturing here is that the nips on the drive side just aren't pulling it hard enough. So I tighten up the upper nips for the lower drive side former board. And it looks like that was it. Now it's pulling a lot smoother across the web. I put the trolleys back to about 2 bar just for good measure to ensure that it continues pulling correctly. Check it one more time, it's still good, and then I just call that problem solved. At this point it's just a matter of checking copies over and over, calling out problems as they appear, checking the margins and heads after the pasters, and getting through the run. Another event that occurred in an unrelated run was I was running along and the paper developed a foldover. The way to get a foldover out is to go up to where the foldover is occurring, and then as carefully as you can push the foldover out. If the paper tears, you will lose the lead. So here I push the foldover out, but then you can see wrinkles developing. So this is why the foldover started in the first place, and I have to get those wrinkles stopped. If you look at the wrinkles, you can see that they're pointing to the drive side. That means that it's tight on the drive side. It's trying to pull to the drive side. The reason it's pulling to the drive side here is because it's pulling to the operator side on the next pipe on the RTF. The reason it's pulling to the op is because I have trolley number 3 a little bit too tight and I have trolley number 4 a little bit too loose. So I'm going to swap those around. I'm going to tighten up trolley 4 and loosen up trolley 3. And as you're doing this, always check the web behind it to make sure that it's still pulling straight, and check between the former boards to make sure that it's not starting to chop or push around anything. After making that adjustment, go around to the back and you can see that it's now pulling nice and straight. On yet another run, I was experiencing a bad fold on the mid-op board. Usually tightening the nips would fix this, but for some reason it's not working now. Behind the board it doesn't look too awful bad, but there is some wrinkling, and on the front of the former board you can see a large gap between the op board and the drive board. I want to push the op board to the drive, so I'm going to start by tightening trolley 4 and loosening trolley 1. That's moved it over a bit. I'm going to also tighten up trolley 3 and loosen up trolley 2 a little bit. It's moved to the drive, but it's still floating a bit. I'm going to tighten up trolley number 4 a little bit more. I'm looking on the left side of the web right now, and you can just see that the trolley number 1 is sitting right on the edge of the image. It should be on the edge of the paper. I'm going to start loosening that one up even more. One thing that's important here is that if I loosen up the op too much, some of the bottom sheets could start burying themselves to the drive, and those webs will then protrude out from the section. I don't want that. I'm looking at the drive side board now, and I can see that it's bubbling out a little bit to the drive, and it's really tight on the op. So I'm going to try and loosen that up to hopefully affect the entire web. So I'm loosening up the trolleys on the drive side board. The operator side board is still pulling to the op a bit too much, so I'm just going to completely pick up trolley number 2. The web on the drive board is still pulling really tight to the operator side, so I'm going to pick up trolley 5 and then just tighten it up just to the point where it's barely touching. And that doesn't seem to be doing the trick, so I'm just going to tighten up both ends of it, so that's trolley 5 and 8, to try and pull the slack out. That's getting better, but there's still a little slack in the middle, and so I'm going to tighten up trolley number 7. And that's starting to look better. It still doesn't look great, but it does look better. So this runs alright for a while, but then a little later on, the sun section starts floating out a little bit. And of course this is going to happen because I had that trolley turned up to 4. So the first thing to do is loosen up trolley number 4. And as soon as I do, the top sheet wants to run all the way to the operator side. So now I've got a mess. I'm trying to loosen up trolley number 5 so the drive side sheet will slack up a little bit and hopefully tighten up the operator side sheet, and put a little pressure on trolley 1 and also drop trolley 2 again. Looking under the board, you can see that that page is no longer pushing out of the section, and the balloon looks a lot straighter, but it's still not great. So I decided to give the nips another shot, and it straightens right up. Periodically, you want to call down to the rear room to let them know how many copies are left. I usually call it around 70,000, 50,000, and 30,000.
Rear room, there's approximately 60,000 to go, 60.
But you do want to occasionally let the rear room know how many copies are left. That way they know how many more rolls they have to put in. When there's approximately 20,000 copies left, you call the packaging department to see if they have any draw changes or waste.
Packaging, do you have any draw change of waste for the main?
Solid price, no draw changes. Give me 350 for pack plate, 350.
Because there might be a last minute purchase, and if there is, then you need to print to account for that. And also sometimes copies do get destroyed in the process of packaging them. So the packaging will give you this number, whatever that number is, you write it down, then hit the PMS button and put it in the waste. So if you unexpectedly waste extra copies, like for example the 1-able red scum that we had earlier, that 200, you want to make sure that that 200 is still correct. So confirm the 200 in run with the packaging department, and then whatever number is remaining at the top by the total heading is the exact number that you run to. The press takes 700 copies to shut down, so if a paster is going to fire during that 700 copy shutdown, chances are you're going to lose that lead and you're going to be short, which means you're going to have to send the lead back up and then start the press back up for just a few hundred copies. So first calculate how many copies you have to go to minus how many copies you have off, and then whatever the remainder is, you check all the reel stands to make sure that they're not close to that remainder. If they are close, call down to the reel room and let them know that they have to do a hand paster on that reel before we shut down. For example, here there's about 10,000 copies to go, and reel 8 is going to be pasting in a little bit less than 10,000 copies. So what you have to do is call down to the reel room and let them know that they have to make a hand paster on reel 8.
Reel room, there's approximately 10,000 to go, and I'm going to need an early paster on reel 8. Early paster on reel 8, please.
One of two things will happen. Either they'll paste it off so that they'll have a nice large butt, or they're going to wait until the press almost shuts down to make the butt as small as possible. If that happens, you'll have to call down again to the rear room to let them know when to paste it off just before you shut down. So when we get close to shutting down, I'm monitoring the reel stand to see how many copies it has left, and when it gets close, I call down to the rear room to tell them to paste it off.
Alright, stand by, and go ahead and paste 8 now. Paste it now, please. Copy that, thank you.
And then when the safe goes off, you know that the paster has gone through. And when there's approximately 500 copies left, I hit the button to do a controlled stop. The reason I hit the button at 500 copies instead of 700 copies is so there'll be 200 copies overrun. You always want to have that because they almost always kill 100 to 200 copies every single time you shut the press down. And that is on account of the heads that jump up and down, and sometimes the scum that develops as you're shutting the press down. Once the press is shut down, go out to the conveyor and hold the blue button to clear the line. And once the counter has stopped counting, write down the net and waste so that the supervisor has numbers to file for their paperwork. At this point, you have to wait for the packaging department to release you, because only they're going to know for sure if you have the exact number that they need. And once they do, copy their release and then let the rear room know that we are done so they can do the changeovers.
Rear room, good job. Breaks off changeovers, and let's get this thing done.
You can disengage the unit so that people can pull plates, and then end the job by hitting the PMS button and then hit job end OK. From this point, the process starts over. You go back into the job screen. You can now delete the job that you just ran by highlighting it and then hitting delete OK, and then load the next job. When all your runs are done for the day and the press is set up and your blankets are clean, the only thing left is to clean out the folder, and you do that with an air gun. The hose is right next to the folder. Plug in the air gun and then blast the folder down. Make sure you lift the doors to get inside the folder and get all the paper dust out. Clean the folder as much as you can, and then when you're done, start from the top, blast the entire folder down, and work your way down to the bottom. If you run the folder long enough, you're going to be expected to be one of the best operators on the crew, meaning you always know what to do, you know what's going on, what's about to run next, and when people have questions, they should be able to ask you, and you should have the answer for it. The supervisor is going to supervise, but you, for the most part, are going to actually lead the crew. And as long as you can show that you can consistently do a good job, that your papers look good, that you don't lose leads, and that you in general don't fuck up, then hopefully you can stay a folder operator as long as absolutely possible. But if one day you do fuck up, then you might be demoted to a supervisor, and I'll be talking about that next.